I think we should get started. Welcome everyone to this SmartDB session with Bryn and Toon, who basically both been presenting and talking about Oracle Database forever. And I'll hand over to Toon to start with to talk about opportunities for SmartDB.
Yes, okay. Yeah, I thought I'd prepare a small slide deck for this second session, just to for two things. I want to bring a little bit of the SmartDB message every time we do an office hour. So I'm going to bring a little bit of the message that I haven't touched upon last time, but also to ensure that if we have any new participants or people who watch the recording and are new to this matter, we always start with a real short explanation of what we mean by SmartDB. So it's going to be 5 minutes, and the plan then is to go into the questions that we had received of last week's session in the Dev Gym area and for this week. Now, so for those who are not yet aware of this, SmartDB is about how you use or fail to use the database. And there's basically two very big opposite ways of using the database. You can use it as just a persistence layer, where you just use it to store rows in tables, or you can use it as a processing engine. I mentioned a full-fledged processing engineer. And by that I mean, or we mean, that it's all about where do you put the business logic. Now, I explained in detail what we mean by business logic last week, so I'm not going to do that again this week, but the applications that we target roughly consist out of 3 tiers. You have the table store at the bottom, stored in the database. At the top we have the interfaces, both human or software interfaces, and in the middle we have the business logic, which deals with all the use cases that you need to build for your application, and which have lots of programmable logic that issue SQL statements towards the database. And we see two mutually distinct approaches of building these kinds of applications. One on the left is where you use the database as just a persistence layer, meaning that the business logic and all the SQL that is being issued towards the database lives outside of the database in a language that's not PL SQL, hence the no PL SQL approach name that we put on the left there. And on the right, we use the database as a processing engine, meaning that we are going to use PL SQL and also set-based SQL statements to implement the business logic for our application. And here we are using the database as a full-fledged processing engine. Now, last week I explained that if you use it the way we depict here on the right side, you might actually A, get much better performance, but B, and this is counterintuitive, be much more scalable. The database will be your bottleneck far later than it will be on the left. And this is totally counterintuitive. We talked about that last week. There's a video on YouTube that you can look at, and in case you haven't seen that yet. And on the right, we call that the SmartDB approach. Now, over the past 25 years, we've seen roughly at a very high level these 3 software architectures. In the 90s, we did everything with client-server, where we had fat clients sitting on our desktops that ran the user interface, that ran the application, the user interface part of the application. And we used a lot of the SmartDB approaches in those years. Then in the new millennium, we've seen the dawn of Java Enterprise Edition and the ubiquitous model view control approach, where all the data logic, the business logic, is being implemented in a middle tier, in an application server that also has a web server that services a browser, a very thin client, thin in the sense that there's no logic anymore in the client side. And the database was just the persistence layer. Now, in the last few years, we've seen the dawn of this whole JavaScript phenomenon to build the UI in the first place, but also JavaScript on servers at times. And we see this approach called model view model being used over in this new architecture. So these are 3 high-level architectures. And the point that I want to make is has to do with the title of this short slide deck, the opportunity for SmartDB to become popular again. If you look at the architecture in the 90s, where everything was in the middle, we used frameworks. We used view frameworks, control frameworks, model business frameworks. And we had basically, I think you could call it a full stack developer that was in charge of everything. Because these frameworks, they sit so tight to each other and they integrate so tightly that it's an all or nothing deal in the middle tier in those days. So we have developers taking care of all these aspects of your application. Now, what we've seen in the past few years is that functionally wise, the whole creating the user interface and also the control bit of the application, so how does the application behave in terms of the page network of this application, has moved, that business logic, that application logic bit of your application has moved from the middle tier to the browser. The browser is essentially, again, a new fat client, because those functionalities were on the client in the client-server era in the 90s also. Yeah, so what this has enabled is, and I depicted that with these two little persons here that I animated, is that you can now also have two separate roles. One developer can be much more focused on creating the user interface of your application, whereas the other developer can be much more focused on implementing the back-end services of your application that are required to make the user interface work. Yeah, so this whole new architecture that we see as a very popular one nowadays is enabling these two separate roles: a user interface front-end developer and a well, I mentioned here Java backend developer, but it could be a JavaScript backend developer if you use Node.js or anything else probably. The point being is that these are clearly now demarked with they are separated with each other via this REST protocol. Yeah, so from the user interface, you just call out to REST endpoints to deliver data that needs to be processed, or you call out to REST endpoints to get data that you want to do something with in your user interface. Now, and the reason why I call this the new emerging world creates an opportunity for SmartDB to revive again is because what you can now also envision is that instead of having a JavaScript backend developer here, you now just have a database developer that creates these backend services for whatever is required on the front end in the user interface part. Yeah, so that's the point that I wanted to make as a starter, as a warm up for this month's SmartDB office hours. So currently we see this REST that's very hip, and JSON being the data format used to implement the payload of these REST messages. So we would have a web server, maybe with ORDS or maybe something else, that opens up the endpoints towards the browser, but basically just acts as a proxy. So every endpoint does nothing else but just call the corresponding stored procedure, preferably a packaged stored procedure in the database. Yeah, and these database APIs in our most ideal SmartDB world would at the moment just do JSON in, JSON out. So they would accept a JSON message, they dissect it, and they start working on it. And depending on whatever needs to be done with it, do it, and then process a JSON message to be output again and sent back to the user interface, where we can then modify the user interface accordingly. So that's the SmartDB high-level architecture as I envision it nowadays. Bryn, anything to comment on this?
No, I don't think so. I think you said that very clearly, and I'll only dilute it if I say more.
Okay, Chris, anything from your side here?
No, I think that was a great sum up. Thanks, Toon.
Okay, any questions on this short slide deck? Maybe now in the chat from the people who are joining us?
Yeah, so if you've got any questions, then please put them in the chat window. We do have some questions that we've had in advance as well. So, but okay, so Dennis, this all emerges as some problematic in development process. I think you're going to need to expand on what exactly you're asking there, Dennis. I'm not sure what he's getting at. I don't know if you, Bryn or Toon, you've got any.
Well, wait a minute. Dennis, is it possible that you're the guy who submitted a number of questions along these lines to the typing interface, the offline interface? Yes, no? Dennis, have you submitted questions using the website? Yes, okay.
Yes.
Well, in that case, I have the list in front of me, and you're ZZA, yes, and we plan to address them. So you needn't type any more at the moment. Let's just come to them. We could come to them more or less straight away, I think.
Okay.
Because after all, it would be nice to let people online type stuff, but we've got a backlog. And last session, we were all acutely aware that we were preaching without really having much bandwidth for interaction. So we're trying to turn the tables this time. So I'll come to your question presently, Dennis, but here are a couple of questions. And before I answer them, I'm going to switch to my slide and just re-emphasize one point, which I hope I can do now. The question is, first of all, where has it gone? Can everybody see this slide? Chris and Toon, can you see this slide?
Not yet, Bryn.
Not yet. Okay, I have shared, but I haven't shared. Right, there's two steps. Do you want to share? And then do you want to share again? Right, now can you see this? Yes.
Connect
so,
with it, yeah.
Right, this is where Toon left us, really. He said that there's a whole world out there where JavaScript developers are implementing the view and the controller part of the whole UI, basically the UI, everything about it. And all they're interested in, I mean, not all, what they are interested in, it's a noble thing, is issuing calls and getting responses. We usually call it REST to save breath, but you could say this is just a way of doing remote procedure call over HTTP. And here are the endpoints. And as far as these guys are concerned, that's the end of their interest. They negotiate with the people who are implementing these endpoints so that everyone agrees on the same protocol, and then each can work to their own skills in their own part of the picture. So moving on then, just to emphasize this, my main point, I say it rather differently from Toon, but really we're just using different words for the same thing, is that these endpoints, after the ORDS has done some semantics-free protocol translation from RPC over HTTP to ordinary Oracle Net, these endpoints are the procedures that Toon talked about, namely the JSON in, JSON out subprograms, each in its own singleton package. I talked about that last time. What are the circles and the diamonds, and what's the gray box and the light gray box? That's the essence to the whole thing. The gray box is an empty schema owned by a user who has, from the get-go, 0 privileges. Let's not be distracted by the inevitable public. Starting point is 0 privileges. And then that user is granted exactly and only execute privileges on each of the intended subprograms here. So these diamonds represent the existence of an execute grant on something in a different schema. And that, in my view, is the essence of the SmartDB paradigm, or the hard shell paradigm. There's tons more. And of course, as always, the interest is in the detail, but the high level position is exactly that. As long as you do this bit right, then that's the main part of the discussion nailed down. And then everything from here on in is all about code classification, which is important, crucially important, but it's a separable point from the basic establishment that the world inside the database is exposed to the world outside of it only through a countable set of very specifically designed subprograms. Okay, now against that background then, here are 2 questions. Both came from reading one of the people putting these questions had read my paper end to end, which pleased me. And the first question is about the point that one of us, probably me, made last week, that by putting your subprograms each in a singleton package, in other words, a package that has nothing but that one subprogram, you are achieving a special benefit over using a top-level function or procedure, in that the execute privilege which you need and which confers the ability to read the source code to package specs, top-level functions and top-level procedures, does not confer that benefit to the body. And I made a big thing that the people on the outside of the database shouldn't be able to discover anything about the insides of the database beyond what you intend. In other words, the API specifications, and by all means, whatever comments you care to put in the package spec to describe the purpose of the various formal parameters. And the question was, why are you making a fuss about that? That sounds to me like security by obscurity. And they referenced the fact that that Apple has said that design of such, sorry, I'll read out what he says. By design, the security of our products doesn't depend on the secrecy of our source code. Why am I making a fuss about things in a different way? And really, it has to do with the difference between some kind of stuff that's installed in your own hands on your own smartphone, and stuff that's installed, co-installed in the environment of who knows what precious data about people's financial positions, their medical histories, their all sorts of sensitive, personally identifiable information that we hear so much fuss about. It's a different game. And it's just axiomatic, I would say, that the world is full of bad guys. We hear about it constantly. And they are seeking ways to hack in. And any information that a bad guy can get about anything that's inessential for the purpose of the system they're trying to hack in is just intrinsically potentially beneficial to them. And it's really a waste of breath to try and examine the detailed mechanisms. Everyone in the security space simply rehearses that point time and again. So I just take it as axiomatic that anything we don't have to reveal and that we so trivially can securely avoid revealing, we most certainly should. And that goes for all the source code. And it also goes for that other part of what I was talking about, the error logging system. Anything to do with what goes wrong must be recorded within this hard shell. And the only thing you can give out is that, I'm terribly sorry, something unexpected happened, and here's the incident number. So I hope that's a sufficient answer to that question. Do you have anything to add to that one, Toon?
No, other than you explicitly mentioned singleton stored procedures, each in their own package.
Yes, singleton packages.
I guess I'm a bit more flexible in that, in the sense that I'm happy to see a package that has a set of procedures that services one particular area of the front end or so.
Right.
All consolidated in a single package.
Yes.
And then,
well, let me return to that point then. I'll explain why I'm so hot about that. And my, I have to go quite a bit forward to get the right slide there. My enthusiasm about that, here it is entirely to do with a feature in Oracle Database, which is new in 12.1. And that's code-based access control. So I hope this diagram isn't too spaghetti-like, but these guys here are the next level in from these guys here. The guys in the dark gray box are the JSON in, JSON out, who act as a shim for the conventionally parameterized PL/SQL equivalents with ordinary PL/SQL data types. And I showed you that maybe some subsystems are interested in exercising the conventionally parameterized PL/SQL. Right, now each one of these PL/SQL subprograms is of course a member of the set which defines the interface. They're not there by accident, they're there because each one has been worked out to be the implementation of a specific business function. And different business functions require to do different things. Some are selecting, and when they're selecting, each of them, whose purpose is only selecting, will be selecting in general from different subsets of tables of what's available in the whole mess. Similarly, those who do changes will be changing in tables, and different of them obviously will be changing in different subsets. In the limit, the subset is one, but it's often a few, of tables within the whole mess. Now, there are two ways of enabling such procedures, such subprograms to do what they want. One is to give them privileges beyond what they need, but nevertheless, which set of privileges encompasses what they need, and argue that, it doesn't matter really if they've got more privileges than they need. Of course, you can argue that very convincingly on a specific case-by-case basis with a fair amount of analysis. But the other stance is the one I take. No, I'm not going there. I'm not having that discussion. There's a well-established axiom out there, the principle of least privilege. It's just taken as a law that anything you do should be done using exactly and only the privileges that you need. You can't do it with fewer privileges than you need, but if you have superfluous privileges, clearly, without examining any of the mechanisms, it's a potential enlargement of the attack surface. So that's simple. And the practical way to give each one of these exactly and only the privileges that it uses is to use the fact that new in 12.1, you can grant, effectively, I'm missing out some words here, you can grant privileges directly to a PL/SQL subprogram. Actually, not to the subprogram, but to the PL/SQL unit that contains it. Ergo, if you have two or several subprograms in the same unit, you've lost the granularity that you want. In a future Oracle, maybe we can lower that granularity so that Toon can have the organization benefit that he wanted. But in my scheme, Toon's world is here, where these guys have their several ones grouped together for various organization reasons that suit you. And these are, again, shims. And their purpose as shims is to be exactly and only the spot to which you grant. And by the way,
maybe I'm not sure if you can quickly find it in the docs. Maybe just quickly show the syntax on how to do that.
I could find it, but I think it would be confusing. Let me see
if I can find it while you keep talking.
I'll speak it out then when I'm talking, but we're going to get escalated into complexity. Basically, there's a level of indirection involved. You don't grant the privilege to the subprogram, or I should say to the unit. Rather, you grant it to a role. So you first have to have the role there, and you grant the role to the unit. And the syntax for granting the role would be grant R to you, in very crude terms, where R is the role and U is the unit. Obviously, there's a little bit more syntax around disambiguate what you mean, but I wouldn't fuss about that. I would just rather say that your intention of granting a role to a PL/SQL unit can be met by using the right syntax, and the syntax is in the book. And then in turn, you grant the privileges you want to the role. And here's a way to seal this lot. Had you insisted on it, well, I'll put it a different way. If you're stuck in 11.2 and you're inspired by this philosophy, how do you achieve it? You could achieve it by having every single one of these in its own individual schema, establishing it as a definer's rights guy and granting the owner of that schema exactly and only the privileges that you need. That would work splendidly. It would just be quite tedious for maintenance. So in this new regime, every single code unit in the whole universe of everything is invokers' rights. And that means that by the time this guy who has only execute and nothing else, comes to invoke these, if there were nothing else, each of these would fail in the sequel it attempts to do, because execute on a unit doesn't give you the ability to do sequel from it. And it's exactly then at the last minute that we give, with the precise granularity that we want, the privileges to execute what should be done. Sorry, the privileges to fulfill the tasks that should be done. See what I mean? Sorry, I know you see what I mean, Toon, but I mean everyone out there.
And I understand, Bryn, that you're currently working on a white paper that details this very precisely,
yes.
Right?
Yeah. Rather more carefully stated, I'm currently working on getting ready to start currently working on it. But yes.
Okay.
Yes, exactly. So, and I'm just going to say, without any shame or embarrassment here, that whole discussion that I just had, which I'm going to assert is only a manifestation of everything you hear everyone in the security space say all the time, is uniquely possible by exploiting, by taking into use the features that you find exclusively within the world behind the hard shell, the world within Oracle database. Okay,
so Bryn, there's been a couple of questions kind of about what you've been talking. One is probably just a clarification. They're saying Singleton packages. So that's just a very granular access control list, or ACL method, essentially.
Fine-grained, yes, if you like to put it that way. The term singleton is just meant to be an ordinary English word that expresses exactly what I'm saying. A singleton package is a package whose spec exposes absolutely nothing at all but one subprogram.
Yep. Okay.
No type declarations, no two subprograms, no exceptions, no nothing, just those things.
Cool. Great. So then the next related question is, so why use packages for this? Why not just use standalone procedures and functions?
Well, I already stated that. I'll again briefly, but if I just repeat the same thing again, we'll run out of time. The execute privilege lets the person who has it read the source code of objects in namespace 1, spec level objects, freestanding subprograms, I'll say that another way, functions, top-level procedures, and packages, and for that matter, type specs, package specs, and type specs, but noticeably not bodies. They're not in namespace 1. So exactly, to hide the people in the middle tier or outside of the database, to hide the source code of your whole project from everyone outside of the database, you must separate the code, in other words, the implementation, the definition from the declaration, and PLC equals package, spec, package body mechanism gives that. I hope that's clear.
Yeah, and there's a second reason, which is also, I think, applicable to one of the questions that was being asked last week, is how to support mocking objects in this whole smart database paradigm. Well, if you have packages, mocking objects in terms of, we have already agreed upon the specifications, so we can create the package spec, but somebody else is still working on the implementation. In the meantime, you would like to mock this object to have it already return data or accept data in some manner, so that you can do your work because you're out there in the user interface trying to access this API. That can then be very easily done because that person can create his or her own private, her own version of the package body in their own private database environment, without having already an implementation available in the source control system that you have and that you might be able to check out. You just mock the package body in your own development environment, which is much easier or much more natural to do if you have all these procedures as singleton packages implemented.
Brilliant. I forgot to do my my animation. Another closely related question, I'll state it and I'll leave this one to Toon, is in this scheme of things where I've got various schemas for various purposes, where do I think that triggers should go? My answer to that would be, that's a detailed question. The main question is these, singleton guys here with execute and everything else hidden in a suitable fashion. But it's an interesting question, so I'll hand that one over to Toon.
Yeah, okay. Well, first, triggers.
And indeed, why have triggers? Yes.
Triggers in the Oracle database developers community is a very controversial topic. I think it has been established through all the work that's been done in the 90s, where triggers have been used in lots of different ways, that triggers that have what's called side effects are generally considered harmful. And by side effects, I mean, for instance, you insert a customer and you have a trigger on the customer table that immediately propagates a sub-transaction or something else towards a bunch of other tables. Because whenever you insert a customer, you want to have something done, and why not do that in a trigger? So that would be a trigger with a side effect, because inserting the customer has as a side effect these other DML statements that get fired by the trigger. This, I think the general consensus out there right now is that that's not the way you should use triggers. It's much better to have an insert customer API somewhere in your layered architecture of PL SQL stored code, and as part of that insert customer business logic, you do all the additional stuff right there, instead of pull it out there and tuck it away, basically hide it away in a trigger on the customer table. Now, so supposing you're not doing those kinds of things in triggers, then I think there's a couple of things left for which you might still use triggers. A very obvious one that's often heard is auditing. If you have some very special auditing requirements, those, and by very special I mean the type of auditing that you could not pre-configure with the audit functionality inside the database, because we have an audit statement in the database, and we can have the database automatically audit a whole lot of stuff in various ways. If you want to audit it yourself in a trigger, be my guest. But then that's always you're always doing transactions towards audit tables. And sort of that's the end station. You probably don't have triggers again on those audit tables, which might get you in this cascading hell of triggers firing, which is the case in the first way that I talked about triggers. If you have a customer trigger that propagates some DML statements towards other application tables, those application tables might also have triggers, and then they fire and it becomes uncontrollable. So auditing might well be a use case. Now, where would you put the audit trigger in that case? I think I'm not, personally, I don't have a really big opinion about that, but I would put them in the code schema. Any thoughts that you have on this, Bryn?
Yes. I think I should emphasize the subtext of everything you were saying, and just bring out a point that was implicit and make it crystal clear. Just imagine a no PL SQL scheme where there are some very rigorous and right-minded data modelers. I know that doesn't often happen, but let's imagine it. So they really, really care about the data model, but for some reason, in the larger picture of the organization, all the SQLs are still coming in from the outside world. And there are various rules about if this happens, then that should happen as well, And one way to get it all right, in other words, to end up so that the database at rest always holds exactly and only the data that conforms not only to the kind of constraint style rules, but the rules about what should happen in what order when things are done. The only way to get that correctness in the database is to trust outside of the database code, which, by the way, in order to function at all, has to just have the ability to go on any table at any time, and therefore anyone in the outside world can go on any table at any time and do things in a weird way. So under those circumstances, you do find that the recourse to the trigger, the problems that you mentioned notwithstanding, is expedient, because you can then, within the world of the database, where at least you have some authority, make sure that certain rules are maintained. or at least give it a far better shot. But all this is it's like a solution to a problem that shouldn't exist. The point is that you can't achieve what you want to achieve in the context of the data model unless you control everything. And it comes back to the basic concept of an API, the functional definition of what's to be done and its implementation. And when the implementation is spread across diverse tiers, you're shit out of luck, basically, when it comes to any control.
Okay, but now it's not, because we're using SmartDB.
Precisely.
Where should the audit trigger go?
That is the point. Now now you just state all your requirements in a very different way, don't you? Let's say that you never thought of auditing, and you've got your functional API, absolutely splendid. And now someone comes along and says, you know what, we should have some auditing. Well, then you have this discussion about what auditing means. What are you auditing? Are you auditing the time of day? Are you auditing the color of the socks the guy is wearing, and all that kind of stuff, And when you've got a functional understanding of the auditing requirement, and only then you work out what to do. And it might well be the case that some sort of uniform intervention in the relatively close to the API guys in ordinary PL SQL code can gather the information that's needed and in a uniform fashion write it away. There's every reason to hope that kind of thing would be possible. It would be just inconceivable unless you were using SmartDB paradigm. So, in one answer to the question, there'd still be no triggers. In another answer, where they really, really, really are triggers that you write because out-of-the-box auditing is not sufficient, and you're convinced that all this lot is as right and proper as it can be, that you're not cascading on and on and on, well, I would imagine that you would, depending on the volume of the number of such things, you might make an auditing schema. Why not? Yeah. The only problem there is a problem here. It's a very practical problem. And it would be solved at a stroke if only someone in Oracle got off their backsides and implemented a way to grant the ability to create create table in schema Scott to Blake. Grant, if we had things like that, we'd be in a different world, but we haven't. And the problem is that when a trigger is not in the schema that the table it should fire on is in, then getting it in place is tricky in various ways. Yeah. Getting it to fire in various ways. And you end up in an elevated privilege regime that you don't want. And the minute anyone has got any privilege, it's just intrinsically bad news as well. And sometimes I think you have to let that rule. And that would mean that the triggers, sorry to say this, just have to be in the same schema as the tables they're on. Because that consideration trumps others.
Yeah. And when I was talking about use cases of triggers, I had a number 3 in my mind. So the number 3 use case for triggers would be to validate constraints that you cannot declare yet in the database. And but these would be triggers that never do DML, because those triggers they just validate a transaction that's just occurred in terms of some data integrity rule that you have inside your database design. And since these triggers only read, in my sense of side effects, they don't have side effects. So they only check the transaction and raise an application error in case it's true. So those kinds of triggers would, in my world, definitely be part of the table schema and not of the code schema. Now, implementing data integrity rules via triggers is a very complex matter. It should not be taken lightly, and let's just leave it at that. That's a whole different topic.
Go on, Toon, we can talk about. Say it. You're too embarrassed. I'll say it. What Toon means is you should all, if you haven't yet, go out there on that community and vote up Toon's proposal for SQL assertions. The basic subtext is that if these things which are solutions to a very common problem and for which the whole theoretical side of it is well understood. If they were done by Oracle, all this whole discussion we're having would just evaporate.
Yeah. If we have SQL assertions, then a whole large use case of using triggers in the database just goes away. Yeah.
Right. Let's bulldoze on to another.
Let's go to another question.
Otherwise, we'll get stuck. I'll give a brief answer and hand this one over to you as well, Toon. The question is basically, do you allow the PL SQL hard shell API to include views? Right. That's the question. And I'm going to answer it very mechanically and then hand over to Toon for the real answer. The answer is obviously no, because by definition, a PL SQL API is a set of PL SQL subprograms, and a view is not a PL SQL subprogram. End of discussion, right? But really, I guess the question is, how do you arrange that clients who want to do SQL can get that SQL done? Presumably, exercising some freedom on how they compose it, doing row by row SQL if they think that's good. Over to you, Toon.
Yeah, so I have seen views being used in pretty good SmartDB projects, 10, 15 years ago, where
just one second, we'd have to say SmartDB primed, SmartDB, softened.
But that was in the days when we were still using model frameworks in the Java middle tier. And because some of these model frameworks, they just really like to do SQL, preferably against raw tables and not views at all. So in those days, I would allow views, but in the current time that we're in, with the JavaScript way of building these front-end applications and the REST way of communicating with back-end services, I don't see the need anymore to allow views in the sense that I would have allowed them 10, 15 years ago. It also, another question in this same area that I often get is, do I allow stored procedures that return a ref cursor? That's a very common question in the same area. Here again, I would say no, because if you return a ref cursor via a stored procedure, you then lay the burden of fetching rows outside the database. And to me, doing a fetch is like doing just a SQL statement outside the database. And I would never want to have that. I would just want to return exactly the rows, and preferably nowadays as a JSON message, that are required for whatever page is out there that needs to display a couple of rows. Fetching rows is not the only responsibility that you then immediately put in the different realm, so not in the database realm, but on the application server realm, or even in the client realm, if you, depending on the architecture that you're using. You're also putting the burden of closing that cursor outside the database, yeah, and the risk of leaking cursors, or where clients forget to close these cursors, is very real and very high, and is often the reason why DBAs get often asked to increase the open cursors all the way up to 10,000 or even higher, because then we can make the weekend and then we can bounce the database and we're good for another 5 work days. So if you're currently in this new paradigm, in this new JavaScript architecture paradigm, with preferably just a REST server in the middle, I would not want to use views anymore as a database API. No.
Good. Right. Let's. That's all the questions, I believe, that were outstanding from the first session. Let's move on to some of the ones that have come in from the second session.
Well,
some
so
of them...
Bryn, so just going back to some of the things you were talking about earlier, we had a question coming about the Singleton packages and so on, and saying, is it correct to say this more granular access was mainly intended for invoker rights? And it goes on, for definer rights, which is the primary choice when it comes to ensuring security, this is less relevant.
Yes. The question is worded in such a way that it includes assertions, and those assertions are groundless in the world I'm talking about. So it's a slightly tricky word game here. Before we had code-based access control, before you could grant privileges to code units through the intermediary of a role, then definers' rights was exactly the way that you achieved the effect of privileging a PL/SQL unit to do the task it needed to, while the user who had the execute privilege on that unit had no privileges to do the SQL operations themselves, okay? That was the only mechanism. And in that regime, as I explained, you could always get ultimate fine granularity by having every single definer's rights subprogram that implemented the API in its own schema and granting the owner of that schema the privileges needed, okay? In that regime, if you were being careful and using that whole multi-schema approach, everything in that world would be invokers' rights except the API, and the API would be definers' rights in the way I mentioned, okay? Now, what code-based access control does is liberate you from the tedium of so many, many different schemas, one for every single subprogram, and rather it lets you have them all in your API schema and grant the privileges that you need to each unit within that schema using the code-based access control mechanism with the right set, okay? So the fact that we now have code-based access control turns that whole discussion on its head, and in the scheme I described, there is literally, there's almost not a single in definers' rights unit present, okay? So the world changes, so you have to think differently. Where do I use a definers' rights unit? This is very practical, low-level detail, but I found it useful to have common declarations, like, for example, the biggest varchar 2 you can have, like Stephen Feuerstein is always talking about, have a package with subtypes in it. Also, types and subtypes who were the various, table row shapes and so on that I needed to communicate between these layers. And that package that defined those types, obviously it was only a spec, did no SQL. And the definers' rights versus invokers' rights discussion is relevant not at all at compilation time. It's only relevant for the SQL that comes out of something. So when no SQL comes out, you may as well have it define as rights. So I hope that made that point clear.
I think that was good. Thanks, Bryn. I don't think there was any other questions come in specifically.
Okay then, so let's move on then, because we may manage only one last thing in this space. There were a number of questions that came in from, it was that guy, ZZ something, I forgot his other name now, but they're all embroidering on the same theme, so I'll try to paraphrase. It's really, how do you do the development process when your aim is to be SmartDB? How do you do version control? How do you do continuous integration? How do you have check-in, check-out? How do you manage with the fact that the database is a harder thing to sort of just instantiate and wipe out, and instantiate and wipe out, and how do you manage the fact it's got data in it, on and on and on and on. They were all really those things. And Toon and I talked a lot about this yesterday, and I'll just turn over to Toon.
Okay.
Or less, I could say something to Toon. I seem to have been talking more than I thought I would. Do you want me to start, or should you?
No. So yeah, I get these questions offline frequently. Let's say once a month, and my first answer is, well, suppose you're not doing SmartDB. So you're developing everything in JavaScript or Java. You're using IDEs that support you building that code, and you're using Git or Subversion or what have you to check in all your source and to branch and to merge and do all kinds of things. In that regime, you also have very likely create table scripts, right? Yeah, they say, yeah, right, we have create table scripts. And they version control create table scripts. And they version control create index scripts, and maybe they version control create sequence scripts. Those are typically the 3 types of objects that you see in NoPL-SQL kinds of projects. And when they move from a release 1 to a release 2, they might have, instead of a create table script, a couple of alter table scripts, or drop index and recreate index scripts in different ways. So you're already doing version control of files that basically constitute sources that should be run, or that should end up being run in the database. What's the difference by just adding more script types in that whole process that you already have? So now you're going to introduce create package body scripts. You're going to introduce maybe create view scripts, create all kinds of other types of scripts, and you version control them in the same way as you do those few scripts that you already now have. Liquibase is a framework that I often hear being used to run scripts in the database in those kinds of objects. Well, you can use Liquibase and configure the running of all these kinds of stored procedure scripts that have all the business logic of your SmartDB application in it. So there's a part of me that says I don't really see the problem, but there's another part of me that says maybe I don't yet fully understand the problem. But at the moment, I'm at the position that I don't really really see the problem, as I think you're already doing this, only you're doing this a very little bit, and it becomes full-fledged if you go SmartDB.
I'll have a go at this too, but in a rather different way. I talk to a fair number of customers, especially I've got to get this word in somehow. I talk to a lot of customers who are interested in adopting EBR. There, I've said it. Edition-based redefinition, it's wonderful stuff. You should know about it. You should use it. Right. When I'm talking to them, I have to ask them, what have they got? And then, have you got any of this? And so on. And then, how do you go about things? How do you do your development? How does it work? And I often ask this question to people at conferences too. I seize every opportunity I can. And there's 2 kinds of answer that come along. One is very straightforward, coherent, and we have the basis for a meaningful discussion. And in that regime, whether they state it explicitly or whether it simply emerges, these people recognize that any deployed database, whether it's a production database or any of the gazillion that you have in the flow to get to the production database, any one of those is just an instantiation of a definition which has its own important existence. And the definition exists in a source control system. And the source control system provides you a scheme to instantiate not only the latest definition, but any definition along the way, including earlier ones that were good and including provisional ones that are at the moment in progress. And the people who work in this way are all focused on the idea that anyone can, in a prototype environment, just copy out anything they want from the source control system, instantiate any version, make all kinds of changes in it, come to all kinds of conclusions, which changes they do by changing some or lots of the scripts that define it. Then the question is, if they think their changes are good, can they get them back into the source control system? And the answer is, of course, no, not unless they sought permission in the first place. And if they did seek permission in the first place, and if they're going to get them back in, only through no end of gates, like a peer review of the code. This is what we do in Oracle, excruciatingly careful peer review of the code, a discussion of things, maybe a meeting lasting an afternoon where people discuss it. Yes, Toon's been at such meetings. And then, of course, when you check it in, it's checked in some kind of provisional space, which occasions no end of mechanical testing and who knows what. I don't think I'm talking out of turn if I say that Salesforce, with whom I've worked closely in connection with the use of EBR, do this kind of thing. They do it as a matter of course. Then there are other people. And dare I say it, they're the people who've taken SQL Developers' ease of use deluxe, where you're connected to a database, you're looking at the source code of a PL SQL procedure, you type a few changes in it, you press save, and it's back there in the database. And the database, particularly when it's populated by many people connecting to it, all doing this, the database kind of becomes your source of truth. And then you get this business of diffing, don't you? You know, you take some definition of DB metadata of the production, you do some corresponding thing of this thing you've got organically in your shop, you work out the differences, you compute scripts who are going to impose the differences back. People do this, don't they? Have you heard of people doing that, Toon?
Yeah.
You're laughing, but you're laughing like I was making it up. No, it happens.
Yeah.
And, well, when you're in a priori, or at least when you've drifted into that second school, then everything is problematic, right? No matter what it is. When you're in the first school of thought, the questions that these people are asking don't seem to arise. You know, as Toon said, well, everything is just various forms of artifact. Damn, what's happened here? I'm not sharing. Everything is just some kind of artifact in your source control system, typically text, but not necessarily. And there's no difference in philosophy whether you're doing SmartDB or not. And don't forget that the system contains artifacts that are relevant outside of the database as well.
There's one important aspect that I forgot to touch upon. So if you're in the dare I say traditional way of building applications, in the no PL SQL way of building applications, everybody has his or her own local application server, right? So and it's in the application server where the highest frequency of code changes happen, because that's where you build your business logic. Now, if you go SmartDB, I do think, and I'm absolutely convinced, every developer should have his or own database sandbox. Because if you don't have your own database sandbox into which you can first check out whatever release or branch that you want to work on, and you get all the source codes, all the DDL script files on your local machine, and you then have tooling like Liquibase or whatever to install those scripts into your local sandbox database, and then you start working on it. Yeah, and only when you then have completed your working, you recheck in your scripts, but it requires to have your own local sandbox. Like in the no PL SQL world, everybody has his or own local JVM sandbox. Yeah, and often in the other scheme of doing things with all the logic outside of the database, people might have been sharing a single development database, because that's an environment where hardly ever any changes took place. All the tables got created once, and then everybody can use them and start building the business logic. So in the SmartDB paradigm, you really would need to organize every developer to have their own database sandbox. I think that's an important thing that I forgot to mention when I was talking. Yeah.
Right, I'm going to grab the screen, and in the last couple of minutes, I'm going to show a little demo. I hope I can communicate the psychological force of it in limited time. So meeting, share screen. Do I want to share? Yes, I want to share. Right. What I've got here is a directory with names to do with different database versions. And if I look at 12.1, you'll see I've got my cloned DB database, I think, all the data files that represent, obviously, the PDB that's at that version. Oh, nothing there. Why is that? Well, the reason is because this is one among many unplugged gold masters. This is it's meant to represent a PDB who is populated. It could be populated with everything so that it is a proper representation of your work in progress project as it is at in-house label 42, right? And the task of the day is to instantiate this, get the scripts that you're interested in, that are part of it, and work in it. How do you do that? A trivial SQL script that you can run directly from SQL+, or at a tiny little bit of extra effort, where's it gone? Wire up to your favorite editor. Okay, so here we are. If I was to I won't even bother to connect and show that it fails. That's uninteresting. I'm just in my editor, I'm doing stuff, I'm changing scripts. I think, damn, I've messed up. I want to reinstantiate my whole database. I go up here, give me a new thing from Goldmaster 42, whatever it might be. Here it is, it's coming. I'm dropping whatever I had before. If there was nothing there before, it doesn't mind. And now it's just, seriously using those straightforward SQL statements to clone you a PDB off an unplugged Goldmaster. There, it's done. How long did that take? Less than 10 seconds. And my whole point here is that I'm in my editor. I'm typing this file. I realize I've screwed up. I want to run my whole battery of scripts again from scratch. Bang, I don't lose focus. I go up here, I say, do the same thing. This will drop and reinstantiate, blah, 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 blah. I'm still thinking about that. How should I, what was going wrong here? Is it done yet? Oh, I'm not quite, wait a minute, blah, blah. Oh, it seems to be done, right? That's what we're talking about. That's what it takes to get every single developer their own private sandbox. Don't forget that to use that feature, you don't need the license because there's only one PDB in your database. And don't forget either that with 18C, once the on-premises stuff is available, so will XE be available. XE gives everyone who is using it as part of their professional job the ability to have a full-on all-options database for any purpose they want, except you can't have much data in it. Obviously no good for production, but having not much data is perfectly fine for a large set of development tasks. So I think the era of, I can't do anything because I can't make every developer have their own sandbox is over. And the point is that exactly and only when you're in the SmartDB paradigm, our whole corpus of engineers need exactly and only an Oracle database and something like SQL Plus for running scripts and their own favorite editor in order to be productive. It's not like they need all the other components, the JVMs and who knows what. So, you get your cake and eat it. This simple PDB cloning thing gives the Oracle database engineer, Oracle database development engineer who's working in the smart paradigm scheme exactly what he needs to have a perfectly private sandbox. One among N of them, cloned off one among N interesting Goldmasters in a heartbeat. Sorry if that sounds like too much marketing, but I feel quite passionately about this because I'm sick of hearing can't work sensibly because I can't get your sandbox.
Okay, thanks for that, Bryn. I think Dennis is identifying with what you're talking about. He's saying he'd love to have a look at your scripts that you've got. So is there somewhere you can share those or
you mean the PDB cloning script?
I believe so, yes.
Well, seriously, I'm not going to share that because it's cluttered with everything to do with my MacBook, where this is where the others. It's all over the place in examples, Tim Hall's blogs, Frank Pasha, all these people, they've all talked about how you drop and create and so on.
Yeah, I know of a very good talk by Connor McDonald, I think 4 or 5 years ago, who had a scheme of managing local sandboxes for developers also, and even without using the PDB-CDB architecture. This may be a topic that I think this is a topic that we should spend a small slide deck on, maybe next time or some future run to discuss various options in this area.
Yes, and in that live presentation environment, I'd be happy to show my code. It's just that, I'd have to write an essay 10 pages long to explain what my MacBook is like.
Okay, so I think that's great. I think, yes, this would definitely be a good topic to follow up on in future sessions. So we're just over the hour now. So I want to thank everyone for joining us. I hope you all found this useful. Please let us know what you thought on the feedback page. And we look forward to seeing you in future sessions. Thanks, Bryn.
In
Thanks,
4
Toon.
weeks, and let the questions come in, and we'll see you then.
Okay.
Bye-bye.
Thanks a lot. Bye
Thank
now.
you all. Bye.